What is up? Wow. Oh, we're loud. Okay, hello. We're working. Sweet. Okay, so I'm Austin. I'm from Austin. I work at Voltage, and I've been a Bitcoin and Lightning developer for about 5 years, and I also help people with developer education and stuff like that. And I'm just really excited about Lightning. I love talking about it, teaching people about it in all manner of ways. And today we're going to have, actually, it's going to be a little technical, but we're going to have a high-level kind of abstract talk because I have about 10 minutes here. And we're going to learn about, I'm going to give you my framing of Bitcoin, how I see Bitcoin. We're going to see how Lightning emerges from Bitcoin and just the power of Lightning, the use cases of it. And so there's going to be a lot of analogies, a lot of abstractions here, but hopefully you'll walk away with a good sense of an understanding of Lightning and hopefully some curiosity and some excitement for what you can do with Lightning. So that sounds like a lot in 10 minutes, but let's get into it. Let's move fast and break things. This is going to be the agenda. We're going to talk about the power of Bitcoin, talk about trade-offs, how Lightning emerges, and we're going to talk about the power of Lightning. Sweet. So first of all, let's look at the functions of Bitcoin, and we're going to look at how those functions work together. So we've got the nodes and the wallets here. Bitcoin is distributed. That's a good thing. The nodes and the wallets, I really think of these as the users. These are the individuals that make up the network. Maybe they're running a full node. Maybe they have a self-custodial wallet. Maybe it's a custodial wallet. But they are the users. They make up the network. And we have the chain. Bitcoin nodes all share global state. This is the chain. We all know about the chain, I'm sure. Okay, another important function. Transactions, they propagate across all of the users' wallets and nodes, and they propagate in something called the mempool, and this is kind of where transactions wait to be added into a block. And of course, miners are the ones that add them into a block. Miners use energy to pull transactions from the mempool and create a new block on the Bitcoin chain. And in doing this, they earn fees and the block reward. Okay, cool. Those are all probably things you knew, but this is kind of how I see these things. I see this as a flywheel that feeds back into itself. So UTXOs, they live on chain controlled by users' wallets. So the users, they are owners. The users have nodes and wallets with their private key, and they're able to spend and move their funds as they please. But those funds, those transactions, they move into the mempools that all of the different nodes are sharing. And from those mempools, the miners, they compete to write a new block, earning transaction fees and block reward. And so I see this as a feedback loop that just keeps going around and around. And it pulls in all manner of incentives and capital and new users, and it is continued to work. I see this as the black hole of incentives, and this is the magic of how Bitcoin works, is all of these pieces, they work together, they feed back into each other, and emerging out of these functions are certain properties that we'll talk about in a second. The other cool thing is, Bitcoin is for enemies. We don't really trust each other. We don't really need to trust each other. We're all kind of in a standoff sometimes. Everyone is acting of their own selfish incentives. And in doing that, they benefit the network. And I think that's a really beautiful thing. We don't expect malevolence or people to have good incentives or act well. We expect them to do the opposite and act selfishly, and that benefits all of us in total. Cool, so trade-offs on the Bitcoin base layer. Trade-offs is probably my favorite word as a developer. I just love talking about trade-offs. But we have these properties that emerge, and these properties have trade-offs. So these properties are good, we like them. For example, decentralization is a good thing, but a trade-off of it is lower transaction throughput, higher latency. Security is a good thing, but it has higher energy consumption, which some people think that's a good thing, but hey, it's quite a big security budget. Immutability and verifiability is a good thing, but privacy is, we are pseudonymous on chain, we're not anonymous. Scalability is a problem, and that's a problem because of scarcity, because Bitcoin is scarce in its block space and its unit value, and we like scarcity. That's what brings up the value of Bitcoin, but that causes higher volatility, higher fees, less fungibility over time. So I think these are good trade-offs, but we're still left in a situation where Bitcoin is not scalable. You can't buy coffee with Bitcoin. So what are we going to do about it? We need to make a layer 2. Let's think of a good way to make a layer 2 from these trade-offs. So a good idea of how to do this might be what if we could reuse Bitcoin security properties, but on that one point of scalability, we improve that. We change something right here because all of these other properties are really good. We don't want to throw them out the window. We want to be able to utilize as much of Bitcoin as we can without making a gross trade-off along the way. Okay, but in order to get this layer 2, we need to understand kind of why scalability is the point we're hitting on. And this brings us back to Bitcoin mempools. This is kind of how I see Bitcoin mempools, as like a 24/7 trading floor of complete chaos. People don't really have a good time in the mempool usually. You only have a good time in the mempool if you go in and you go out very quickly. So it's a stressful place. This is quite literally how you might visualize a mempool. These are transactions from nodes all across the world. There are different sizes representing the number of bytes in the transaction. There are different colors representing the fee rates in the transactions. And this scarce block in the middle, this is all the transactions we're going to get in 10 minutes. So the miner, he's trying to solve this block right in the middle by pulling from all these transactions at the bottom. That is not very scalable. And also fees. Fees have continued to rise. I think this is over the last year. Yeah, so fees usually go up and down, but we are definitely in a new paradigm now. Fees will continue to go up, especially as the price goes up, especially as more users, more L2s start working with Bitcoin chain. Okay, so how does Lightning emerge from these? So back to our kind of stock trading floor analogy, I kind of think of Lightning emerging from two people that have to go to the stock trading floor every day and transact with each other. And at some point, they're like, this isn't a very good deal. Let's create a contract. Let's create a contract together so that we can settle between each other because, maybe we trust each other. And then we don't have to hit the mempool and hit the chain again and again. And so that's kind of how I see Lightning emerging. And this contract is really, it's a simple smart contract. People don't know that you can have smart contracts on Bitcoin, but you actually can. And I think of this as like a bar tab. And so it's a very simple Bitcoin smart contract. We can go on chain and open a bar tab of a certain budget. And once that's open, you can transact all you want at the speed of light, smallest payments you want. And then when you want to close that bar tab, you close it on chain as well. So you're hitting the chain twice in order to open up a liquidity channel and close it. And this liquidity channel is really, it's just a multi-sig wallet, essentially. There's some other fancy stuff going on in there. Talk to me afterwards, and I would love to fill you in. But we're essentially pegging this multi-signature wallet from the main chain. We're able to create a network out of it. So, okay, that's kind of cool. We have a bar tab with Bitcoin, but it's actually a network of bar tabs. It goes beyond that. So our two businessmen, they can shake hands and make a bar tab together, but actually we have a full network of bar tabs that are all connected. And this is how money moves through the Lightning Network. So all of these nodes represent different users running their own Lightning nodes, and the payments they route much like how Tor works in a kind of onion routed network. So it's very cool. It's very different than, I guess, a lot of other L2s. There's no chain here. It's a network of nodes, and the chain that we use is the Bitcoin chain, and we use it in a very simple way. Cool, so what does this enable? This enables instant final payments, which is very cool, literally at the speed of light. We've got very low fees. It's fractions of a penny. Basically, the fees exist as you route through other people's channels. You give them a tiny sliver of a sat as you route through. So that's the only fees, but it's orders of magnitude smaller than on-chain. 100K plus transactions per second. Really, it can be 1 million, 10 million transactions per second, depending on if you're transacting with one party or across the whole network. But really, you can move sats at the speed of light. You've got private payments here, which are possible, but not required. You've got interoperability with different chains, with different protocols. And of course, it is global, it is decentralized because it's a distributed network of nodes. And one important point here, and one of my favorite points, is micropayments. I love micropayments. Have you ever sent someone 1,000th of a penny or 100th of a penny for a cool tweet or for a funny joke? These things are happening today, actually, in Lightning, with hundreds of thousands of users. And so you get all of these advantages, and what's so great about it is it's all secured and denominated by Bitcoin. We did not have to make a bunch of ugly trade-offs. We have the full security budget of Bitcoin, and then we have instant final microtransactions with low fees. That's pretty cool. But the Lightning Network wasn't always that cool. This was Lightning Network in 2018, and there's probably 20 nodes here, maybe 30 channels, something like that. Very humble beginnings. And there was no company that created this, right? This is open source software. It emerged from users that started creating it and playing with it. And today, this is what the Lightning Network looks like. This is actually a real visualization that I snapped from some data website. My node is somewhere on here. It's not that big, though. Not yet. So this is us in 2024. We've got, I believe there's more than 20,000 nodes on the Lightning Network now, at least public nodes. Over 5,000 Bitcoin is locked up in the Lightning Network. And so you can just zap sats across this whole network in an instant, and it just simply works. So the Lightning Network ecosystem, this chart, this is a pretty cool chart, but even this is out of date. I think this was from 6 months ago, and we probably need to double the names on here. The amount of startups and companies integrating Lightning, it is absolutely exploding. We have everything from gaming to infrastructure, wallets, exchanges, social. There's all sorts of companies here. And even today, Proton Mail announced they're gonna have a Lightning integration. So soon, I'm gonna be able to zap all of you your email addresses, and you won't be able to stop me. So this is very cool. There's lots of companies, there's lots of options to integrate, and lots of use cases. But it's not all sunshine and rainbows and ice cream. There's hurdles and there's requirements, and very hardcore ones at that. An always online server. This is an infinitely difficult problem for companies and individuals alike. It's a big one. Of course, you need to lock up Bitcoin. You're locking up Bitcoin in this multi-signature wallet. You have to deal with liquidity from these bar tabs. You need to deal with backups. You need to deal with monitoring alerts. If you're an enterprise, accounting, and taxes. This is a lot of overhead. Why would you want to integrate this, you know? And I think in a lot of ways, this has been some of the friction that has kept Lightning from being adopted so quickly. I mean, we're about 6 years, 7 years in now, or something like that, and we're just now hitting this point of inflection where you can say Lightning works globally, enterprises, Lightning is ready for enterprises, but you still have these hurdles and these requirements. And so I'm bullish on the future of Lightning. I think a lot of these things will become much easier in the future to deal with. But for right now, this is what we do with Voltage. This is exactly what we focus on with Voltage. We're trying to abstract away all this complexity and essentially give you a Bitcoin or a Lightning integration that is just like any other third-party integration that you might have. You just need to hit an API. We'll take the complexity away from you. And we do this with easy cloud deployment. We help you with liquidity. We have open source applications built into the platform, along with data and analytics. So pretty good place to start here with Lightning. We have enterprise-grade security, SOC 2, Type 2 security, managed services, custom development, encrypted backups, all that good stuff. My favorite thing about Voltage, though, is that you're not vendor locked in with us. We are not custodians. You hold the keys to your own node. And whenever you want, you can rip out your node, leave Voltage behind, and run it on your own hardware in the garage. And in fact, I think it would be pretty cool if you did do that. Cool, yeah, so thank you. I would love to talk to you about Lightning more if you're interested. And yeah, I appreciate it.
Austin, thank you so much, man. Thank you so much.